All right, again, number 4, just pause the video and read it for a minute if you need to, but we have florists making grand arrangements and simple arrangements, and then they're trying to maximize their profits. So I've already defined the variables, so we'll go ahead and start there. X, that was the old one. Let's clear all that off. X is the number of, what would I say, grand, and Y is the number of simple. If you're coming back in just now from taking pictures, we're working number 4. If you're coming back in from pictures, we're working number 4. All right. Number of grand, number of simple. Phrases. The first phrase is this one. All right, the first phrase, at least twice as many simple as grand. At least twice as many simple as grand. And I know from experience that statement is one of the hardest to turn into an inequality because it just doesn't really make sense. So we're going to explore that in a minute. That's one of the harder ones. It really is. All right, the next statement, they only have 2,394 minutes, which is basically 40 hours. I changed the problem from a couple years ago when it said 40 hours so that the answers are nice and pretty. Okay? So 2,394 minutes, almost 40 hours. So the statement is no more, I think it was no more. Yeah, can only work, so no more than 2,394 minutes. Any other phrases? Let's see if I write a little dot right here, if it'll come back to there now. I doubt it. That's it. Those are the 2 phrases that limit your production, the florist production of grand and simple arrangement. All right, now let's think about the easier of the 2, the 2,394 minutes. So I'm going to think about the second one first. I need a concrete example, simple and grand. Concrete example, any 2 numbers that aren't already in the problem, make them somewhat reasonable. What's reasonable? Who knows? Maybe we'll miss it, but we'll try. What you got? And also make them easy to work with mentally. Like 10 is easy to multiply in your head. 30, 40, 50. Don't pick 7 and 11 or 7 and 13. All right, because that just, so pick easy numbers. What you got? Okay. You're saying a florist can make an arrangement in 18 minutes and a simple in 10 minutes. Those might sound like restrictions, but they are facts that are going to end up influencing whether or not they've got enough minutes in the day. See that 2,394 minutes? The fact that they make 18, it takes a grand 18 minutes and a simple 10 minutes, we're going to use that to determine can they make this many grands and simples with the restriction of only that many minutes, 2,394 minutes. So those are statements of fact that apply to an already identified phrase. And I know it's confusing to pick those out, but you remember the cars and buses? The lot only had 600 square meters, but then a car took up 6 square meters and a bus took up 30 square meters. Those were statements of fact that were going to influence can they fit in the 600 square meters. So it's confusing to pull it all out. But now, with that in mind, I'm going to pick a number of 30 grand and 50 simples. I don't even know if that's even close. All right, again, sorry for all of the announcements on the video and the pausing. We've got pictures going on. But 30 grand, 50 simple. Can they do it? Can they make that many? All right, so 30 and 50, sorry again for the pausing. 30 and 50, can we do it? Is there enough minutes in the day or enough minutes in the restriction, 2,394, to make this happen? This is where, JD, you were just talking about the 18 and the Those 30 grand arrangements take, according to the problem, 18 minutes each. So it should be 30 times 18. And then the 50 simple take up 10 minutes each. So multiply that by 10. So our concrete example would say 18 times 30, 10 times 50. Do we have enough minutes to do that? You multiply those two, 18 times 30, 10 times 50, and add them up. That'd be 500 plus, what's that, 3 times that, 540. That's 1,040 minutes. Can they do it? And you're shaking your head yes, because you're checking that number that I just said out loud, 1,040, to see if it's smaller or equal to the 2394 that's available. That makes sense. That's what the concrete example does, is it allows you to play with the numbers that are in the problem, and to really, you're playing with the X and the Y. It feels more natural to play with the numbers 30 and 50 than it does to play with X and Y. All right, but when you wrote a 30, it was your X. When you wrote a 50, it was your Y. So 18X plus 10Y has to be less than or equal to 2394. All right, now for probably the most confusing of the two. The phrase, at least twice as many simple as grand. All right, I'm going to go to a blank screen here. And I'm going to put two numbers on the page. 20 and 10. All right, if we were doing this in class, I'd be over here on the board. There's those Post-its. Okay. Which one is simple and which one is grand? Think about it. Don't take your time. Think about it. Take your time. If you're wanting, I'll go back to the phrase, twice as many simple as grand. Twice as many simple as grand. Which one's simple? Which one's grand? Oh, okay, so you're saying that if you want twice as many simple, it needs to be the bigger number. So this is simple, okay. This is grand. Now, which is X, which is Y? Go back to you labeled them already. Which one's X? Grand is X, simple is Y. Grand is X, grand is X, simple is Y. Now, it's easy. Your answer is either Y is greater than or equal to 2X or X is greater than or equal to 2Y. It's one of those two. It's one of those two inequalities. But which one is it? Which number do you double to equal the other one? Okay, if I double Y, I get 40. Y is a 20 on the board, and we've already established that Y is 20. It made sense, right? If I double a 20, it gives you 40, which is not how many grands it's on the board. Which one do you really double? You double the grand to make the Y, so you double X. Your inequality is this one, not that one. And I get it. When you read the words out loud to yourself, when you say that you want twice as many simple, you are tempted to put the 2 with the Y. It just feels right when you read the words. But it doesn't feel right once you break it down. All right, so Y is greater than or equal to 2X. And then we go back to the word problem. Go back to the word problem. Cross out everything we've used. And we got profit, $10 for simple, $25 for grand. $10 for simple, $25 for grand. Are you getting good enough at this where I don't need to use the concrete example here? No? All right, then let's use it. How much money did you just make with 30 and 50? Giving that phrase, what do you do with the 30? Multiply the 30 by 25. What do you do with the 50? Multiply it by 10 and you add them up to make that profit, right? So your equation is 25x 10y, 25x plus 10y. Then last but not least, your logicals, you can't make negative number. So x is greater than or equal to 0, y is greater than or equal to 0. You can't make a negative number of flower arrangements, either one. You still need to graph it. You still need to find the vertices of the feasible region and plug them into the profit function and maximize. But I'm going to stop the video there because that's the hard part.